Greetings, this is Chemistry with Nav. In this video we're going to take a look at the equilibrium constant and Kc. So let's start with exactly what a dynamic equilibrium is. Well, a dynamic equilibrium is established when a reversible reaction, so that's anything with one of those signs in the middle of it, occurs in a closed system, which simply means that nothing can come in or out. So it's like putting some gases in a jar and then sealing the top so that nothing can actually enter or escape. In a closed system, when the rate of the forward and backward reactions are equal. So if you take some sort of reversible reaction, let's use one that is hopefully familiar. So N2 plus 3H2, reversible reaction, try again, plus 3H2 going to 2NH3. Well, that's because nitrogen and hydrogen put together do form ammonia, but at the same time you'll find that ammonia decomposes back into nitrogen and hydrogen. So if you were to take an overall view on that, you could say that N2 and 3H2 is in a reversible reaction with 2NH3, because both of those equations are occurring at the same time. So that's to do with the reversible reaction. This is in a closed system, so we assume that there's no other reactants trying to get in and interfere. But if the rate of the forward and the backward reactions are equal, then what will happen is that even though both processes are occurring, you'll find that the concentrations of the products and of the reactants remains constant. So it looks like nothing's happening, but actually both of those processes must be occurring. Okay, so let's move on then to looking at Kc. And for some generic equilibrium where we have A amount of A plus B of B going to D of D and E of E, that may look slightly overly complicated, but the little lowercase letters there are the stoichiometric numbers. So it might be 1A plus 2B goes to 3D and 1E. So we have to have numbers in there as well. If you have that equilibrium written out, then the Kc expression is given as the concentration of D to the power of little d multiplied by the concentration of E to the power of little e, all over concentration of A to little a times the concentration of B to little b. And what that is really is looking at the concentration of the products over the concentration of the reactants. So the Kc expression tells us about the ratio of what products and reactants that we have present in that mixture. So let's look at the value of Kc. Well, if Kc is much greater than 1, then the equilibrium lies to the right hand side. Let's look at the expression above. If Kc is much greater than 1, that means that the numerical value for the concentration of the products must be much greater than the numerical value for the concentration of the reactants. And if that's true, then that means we are getting a lot of products, so we have a high yield of product, which means our equilibrium lies to the right hand side. It means that we are getting what we want. If the reverse happens, if Kc is much less than 1, then the equilibrium lies to the left hand side. So again, go back to the expression above. If it's much less than 1, then the numerical value of the reactants must be much greater than the numerical value of the products. So that means we end up with a fraction. So that's why it's less than 1. But that also means that we have a lot of reactants present and not a lot of product. So our reaction is not going forwards as we want, so it lies to the left-hand side. If we now just look at the units of Kc, the units depend upon the exact equilibrium that you are looking at. So here if we have PCl5 going to PCl3 and Cl2, our Kc expression is given by the concentration of PCl3, so the square brackets is concentration, multiplied by the concentration of Cl2 all over the concentration of PCl5. But if we take that as units, then actually the units of concentration is moles per decimeter cubed, multiplied by moles per decimeter cubed, all over moles per decimeter cubed. Which means that those will cancel, and that's equivalent to just 1 mole dm minus 3. So in this particular expression, for that PCl5 decomposing into PCl3 and Cl2, the units of the value of Kc will just be mole dm minus 3. And let's just finish on one little fact that is often examined. Kc is only affected by temperature. Very often in exam questions you're asked about the effect on Kc of changing the pressure or of changing the concentration. It is not affected by pressure or concentration. And there is usually a mark for making that statement. It's not affected by pressure or it's not affected by concentration. So do make sure that you are happy with those units and also the way to make your Kc expression, because that's relatively easy marks. And remember that Kc is only affected by temperature.